Then we can consider rate of change of its circumference with respect to time or with respect to r, rate of change of area with respect to r or with respect to time. That means here we have to use the chain rule. First of all, we have written formulae of surface area and volume. Then we have obtained ds dt as well as dv dt. Then we have put the values here on the left hand side and calculated. We get this result. Then to get this ds dt form, we have written like this. Already I have started discussing the meaning of derivative or dy dx in the earlier class, and I have discussed the general meaning of dy dx, also the meaning of dy dx in case of y equal to fx, a curve. Dy dx general meaning is that rate of change of y with respect to x, and geometrical meaning of dy dx is that it is the slope or gradient of the tangent to the curve y equal to fx. If we take the angle made by the tangent to the curve y equal to fx at xy be psi, then as per the meaning of dy dx, geometrical meaning rather, dy dx is equal to tan psi. Next, I am going to discuss the other meaning of dy dx, that is known as physical meaning. I shall first take the common matter. Let a particle start from a fixed point. We name the fixed point as O. A particle moves along the straight line OX from the fixed point O. Generally, we call it origin. At time t, it traverses the distance x. Then, after a small period delta t, it further covers the distance delta x. Then we can say the distance x is a function of t, as the distance covered by the particle depends on time t. Therefore, we can say x equal to at. Therefore, as per that description, x plus delta x is f of t plus delta t. Therefore, delta x is equal to f of t plus delta t minus x, that is equal to f of t plus delta t, delta t minus ft, as x equal to ft. Therefore, delta x by delta t is equal to f of t plus delta t minus ft by delta t. Delta x by delta t, we have got this one. This is average change in, say, distance with respect to time. Now, if this change in time, that is delta t, be very small, when delta t tends to 0, then delta x delta t is the instantaneous rate of change of displacement that is velocity. We denote velocity by v, therefore v is equal to limit delta t tends to 0 delta x by delta t. Initially we take the movement of the particle in straight path, but when delta t is very small, then that path may be curve also. This is nothing but, as per the symbol of derivative, v is equal to dx dt. Now, similarly, if we take the rate of change of velocity, then we get acceleration. Limit delta t tends to 0 delta v by delta t. That means after time t, velocity of the particle v, and after the gap of delta t time, its velocity becomes v plus delta v. Then if we calculate in this way, we will get acceleration is equal to limit delta t tends to 0 delta v by delta t, which is dv dt. Also, acceleration is equal to limit delta t tends to 0, or we can take this dv dt like this, d dt. In place of v, we put dx dt. Therefore, it becomes d2x dt2. These are very useful for the students who are reading physics. Therefore, acceleration is equal to d2x dt2, also dv dt. Again, we can write dv dt dv dx into dx dt. I have used here chain rule. Now dx dt is again v, therefore it is v dv dx. Thus we have got three expressions for acceleration. Here, keep in mind that time gap delta t is very small. Therefore, three expressions for acceleration are dv dt, d2x dt2 and v dv dx. We use any of these three forms as we require. Now, I have discussed here physical meaning. This is first case actually for velocity and acceleration. There are different meanings. Now I discuss other meanings briefly. Actually, we are discussing the first part of differentiation or derivatives or differential coefficient. The other part, which includes second order derivative or higher order derivatives, as well as interpretations, different interpretations of derivative in the second part. Next case is case B, when perimeter area of triangle as well as quadrilateral, also circle, depends on length or, in case of circle, radius. If each side of a square, generally we consider the cases of regular polygons. When we consider square, let each side be x, then therefore perimeter unit area side may be dependent on t or perimeter area may be dependent, you see, are dependent on x, then we can consider in case of perimeter dp dx, that is rate of change of perimeter, also dA dx, rate of change of area with respect to x, that means with respect to its side. Also this may be dependent on time. In those cases we consider dp dt, dA dt. Therefore in case of plane figures, dp dx or dp dt and dA dx or dA dt, these are considered. That means rate of change of perimeter with respect to its side, rate of change of perimeter with respect to time, rate of change of area with respect to x, rate of change of area with respect to t, time. In case of triangle, generally we consider equilateral triangle, rate of change of perimeter, rate of change of area may be considered. In case of circle, if the radius be r, then we consider circumference as well as area. Then we can consider rate of change of its circumference with respect to time or with respect to r, rate of change of area with respect to r or with respect to time. That means dc dr or dc dt, dA dr or dA dt as per the given conditions. Next, we also consider the cases of surface area and volume of solid objects. In case of, say, cube, each edge say x, then surface area TSA, rather total surface area, will be 6x square, volume x cube, of course cubic units. Then we consider, if I call it a dA dx, that means rate of change of surface area with respect to its edge, or dA dt with respect to time. Volume is denoted by the symbol V. Then dV dx, rate of change of volume with respect to its edge, or dV dt with respect to time t. Also in many cases we use derivative of given function. Now this will be very much clear if we consider few examples. this sum first. We have to find the average rate of change of y equal to x square in x equal to 2 and x equal to 5, and the rate of change of y at x equal to 2. Here delta x equal to 5 minus 2, that is 3, and f2 taking fx is equal to x square, f2 equal to 2 square 4, f5 that is equal to 5 square 25. Therefore f5 minus f2, 25 minus 4, 21. Therefore average rate of change in x equal to 2 and x equal to 5 is f5 minus f2 by delta x, that is 21 by 3, 7. No unit is mentioned here, therefore this is the average rate of change. Now we have to find the rate of change of y at x equal to 2. For that, second part, y is equal to x square, therefore dy dx, that is equal to d dx x square, that is equal to 2x. Rate of change of y at x equal to 2. That means this is the rate of change of y at certain value. Therefore, rate of change of y at x equal to 2 is dy dx. We denote like this, x equal to 2. Now we put the value of x in this expression, that is 2 into 2, that is equal to 4. Therefore, rate of change of y at x equal to 2 is this. We express that by writing dy dx at x equal to 2. It is read like this, dy dx at x equal to 2, that is equal to 4. That is the answer. Therefore, for the first part, this is the answer, and for second part, this is the answer. Now, I consider this one. You see, a ball covers a speed in t seconds given by this expression, s equal to 80 minus 10t square. We have to find the velocity of the ball at t equal to 2 seconds. Given s is equal to 8t minus 10t square. Now the velocity already I have deduced. In case of xt, x is the distance covered by the particle, t is the time, then velocity is dx dt. Here s is the distance covered by the ball, therefore ds dt is equal to ddt 80 minus 10t square ddt 80 minus ddt 10t square. We have applied the fundamental theorems of derivative. 8 is constant, ddt of t minus 10 is constant taken outside, ddt t square. ddt of t is 1, therefore this is 8 minus 10 into 2t. Finally, minus 20t. That is the velocity. Therefore, velocity at t equal to 2 seconds is equal to, we put t equal to 2 seconds here, 8 minus 20 into 2. Minus 32. Here the unit of distance is feet and time is s. Therefore, finally we have to put velocity will be minus 32 feet per second. S is in terms of t, therefore ds dt, that is the velocity. We have calculated first ds dt at any time t, then I have put the value of the time t, that is equal to 2s, and calculated the velocity is minus 32 feet per second. Find the coordinates, find the slope of the tangent to the curve y is equal to 2 root x at 1, 2. We have to find the slope of the tangent for this given curve. Y is equal to 2 root x, therefore dy dx is equal to ddx 2 root x. 2 is the constant, therefore it is taken outside, then ddx x to the power half, that will be 2 into form of the form x to the power n, therefore half x to the power half minus 1, that means 1 by root x. Now dy dx, the geometrical meaning of dy dx is the slope or gradient of the tangent to this curve y equal to 2 root x at any point xy. Therefore, we have to find the slope of the tangent. Therefore, the slope of the tangent at 1, 2 is equal to dy dx at the point 1, 2. Now dy dx is this one, 1 by root x at the point 1, 2 means here x equal to 1, y equal to 2. This is x, not 2. Therefore, it should be 1. Therefore, slope of the tangent to the curve y equal to 2 root x at the point 1, 2 is this one. It is required to find the angle of the tangent with the x-axis to this curve at this point. Therefore, already I have mentioned, if psi be the angle made by the tangent to the curve at the given point, then tan psi is dy dx at the point 1, 2, that is equal to 1, means tan 45 degree. Therefore, psi is equal to 45 degree. That is the angle made by the tangent to the curve y equal to 2 root x at the point 1, 2. Next sum, we have to find the coordinates of the point or points on the curve, this one, y equal to x plus 1 by x, where the tangents will be parallel to x-axis. Tangent, we don't know whether more tangent, therefore I write tangent within brackets will be parallel to x-axis. Therefore, psi is equal to 0. From that, tan psi is equal to 0. Slope will be 0. Therefore, dy dx equal to 0. Now, y is equal to x plus 1 by x. Therefore, dy dx is equal to ddx x plus ddx 1 by x. We can skip the steps like this. I have not written ddx of whole. I have applied this one. Next step, that is 1 minus 1 by x square. Now, dy dx is equal to 0, which implies 1 minus 1 by x square equal to 0. From that, x square equal to 1. Therefore, x is equal to plus minus 1. Therefore, at 2 points, the tangents to this curve will be parallel to the x-axis. For one, x will be 1, and for the other, x will be minus 1. Now, I rub this part to finish the sum. For x equal to 1, y is equal to 1 plus 1 by 1, that is 2. For x equal to minus 1, y is equal to minus 1 plus 1 by minus 1, that is minus 2. Therefore, the points on the curve y is equal to x plus 1 by x, where the tangents will be parallel to x-axis are 1, 2 and -1, -2. Thus the sum is solved. Change of a circle, the rate of change of the radius, not the circle, of radius of a circle is 1 by pi. Find the rate of change of its circumference, Here, rate of change of radius means the radius is increasing. Since sign is positive, therefore rate of change of radius means it is increasing. Here, with respect to time, that means dRdt is given. Solution. Given dRdt is equal to 1 by pi. Circumference of the circle C is equal to 2 pi r. We have to find the rate of change of this circumference. That means we have to find dc dt. Therefore, dc dt is equal to ddt 2 pi r. 2 pi is constant, therefore the result will be 2 pi into dr dt. Now dr dt is given, therefore dc dt is equal to 2 pi into 1 by pi, that is equal to 2. That means rate of change of circumference, rate of change of circumference is 2 unit. This is actually unit of length per unit time. Let me repeat. Rate of change of radius is given, that means dr dt is given. Circumference C is 2 pi r. We need dc dt and calculated dc dt equal to this one. Therefore, dc dt is equal to 2, which is independent of any variable. Therefore, that is constant. Therefore, rate of change of circumference is 2 unit. Here, we have to mention the proper unit. Ct for C length, that is 2 unit, that is of length, and T means unit time. Therefore, the sum is solved. Next sum. I rub this part first and write the sum. Sum number 6. the surface area and volume of a sphere of radius r and r is and v respectively. Then we have to show two dv dt is equal to r into ds dt. For a sphere, radius is r, s is the surface area, and v is the volume. Therefore, we have to solve this one. Here, s, that is surface area of sphere, that is 4 pi r square, and volume 4 by 3 pi r cube. First I find ds dt. Now ds dt is equal to ddt 4 pi r square. 4 pi is constant. 4 pi into ddt r square, that is equal to 4 pi into, this is function of r, therefore this will be ddr r square into dr dt. Here I have applied chain rule. Already I have discussed the matter in the earlier classes. Finally, the result will be 4 pi into 2r into dr dt. Therefore, ds dt is equal to 8 pi r dr dt. Then we find this is ds dt, dv dt. V equal to 4 by 3 pi r cube. Therefore, dv dt equal to ddt of 4 by 3 pi r cube. 4 by 3 pi is constant, that is taken outside, into ddt of r cube. dv dt is equal to 4 by 3 pi. Now this is function of r, therefore we have to apply here the chain rule. Therefore, dv dt is equal to 4 by 3 pi into derivative of r cube with respect to r, 3r square into dr dt. 3 cancelled. Finally, 4 pi r square into dr dt. Therefore, we have to prove this one. LHS is equal to 2 dv dt already we have got dv dt, this one 2 into 4 pi r square into dr dt, 2 into 4 pi r square into dr dt, that is equal to 8 pi r square into dr dt. Now we find 8 per pi r dr dt, that is equal to ds dt. Therefore, I can write this r into 8 pi r dr dt, which is equal to r into ds dt, that is equal to RHS root. Follow, here we have to use the chain rule. First of all, we have written formulae of surface area and volume, then we have obtained ds dt as well as dv dt, then we have put the values here on the left hand side and calculated, we get this result. Then to get this ds dt form, we have written like this. Also, you can calculate independently left hand side as well as right hand side, then you will see both sides are equal. We have to find the coordinates of the point lying on this curve y equal to 1 plus 2x minus 3x square, where the tangent drawn makes 45-degree angle with the positive direction of x-axis. As per sum, since the tangent is making angle 45 degrees, therefore tan psi is equal to tan 45 degree, that is 1. Therefore d dx, dy dx, tan psi is the slope of the tangent to the curve. Therefore dy dx, that is equal to 1. dy dx, that means d dx of this one, 1 plus 2x minus 3x square is equal to 1, or d dx 1 plus d dx 2x minus d dx 3x square is equal to 1. Therefore this is 0, 0, this is 2 minus 6x equal to 1, or 6x equal to 2 minus 1, that is 1. Therefore x equal to 1 by 6. Now we have got the value of x. Now if we put this value here, therefore y when x equal to 1 by 6 is equal to 1 plus 2 into 1 by 6 minus 3 into x square means 1 by 6, 1 by 36. Now we simplify. 1 plus 1 by 3, that is 4 by 3, minus 1 by 12. We calculate that. (16) minus 1, 15 by 12 by 4. Therefore, I write here, or here, Therefore, coordinates of the point on the given curve where the tangent makes 45 degree with the x-axis, with the positive direction of x-axis, or we simply say with the x-axis is same. Or 1/6, 5/4. Therefore, the sum is solved. I repeat, given curve is this one. We have found dy dx. Since the tangent makes angle 45 degree with the x-axis, that means tan psi is equal to tan 45 degree is equal to 1. That means dy dx equal to 1. I have used that and got the value of x. Now, for getting the value of y, we have to put this value here. And I have put the value and obtained this value. Therefore, coordinates of the point on this curve where the tangent drawn will make angle 45 degree with the x-axis is this one. Therefore, the sum is solved. Now, this one. V is given. Already I have discussed that acceleration is rate of change of velocity, that is dv dt. Therefore, to solve this sum, first we find dv dt. Therefore, dv dt is equal to d dt 60 square minus 2t cube, that is equal to d dt 60 square minus d dt 2t cube, that is equal to, this will be 12t minus 6t square. Derivative of 6t square with respect to t, 6 is constant outside, d dt of t square, that is 2t, therefore finally 12t. Then d dt of 2 cube, 2 is constant taken outside, 2 into d dt of t cube, d dt of t cube is equal to 3t square. Therefore finally this one. Therefore acceleration of the particle at t equal to 4 second is equal to dv dt t equal to 4s. Now we have to put the value here, 12 into 4 minus 6 into 4 square means 16, that is equal to 48 minus 96, that is minus 48. Now since acceleration, we have to put proper unit. Here unit of time is not mentioned, just we write here unit length per second square. Unit of acceleration is unit distance by unit time square. That is why I have written like this. Therefore, this sum is solved. Now, I have worked out so many sums on rather application of derivatives. Actually, more detailed matter will be discussed in the second part. Actually, that is discussed in class 12. That means part 2, when I shall discuss those detailed matters will be discussed. Now I work out few more sums on derivatives. Few more. Though I have worked out many sums on derivatives, I think few more sums are to be solved for you, so that you will be skilled enough. Now I am going to working out few more sums on derivatives. I have written already sums on the board. Now I work out one by one. First of all, number 1. Fx is defined like this. We have to show that fx is differentiable at x equal to 0. First we write down the condition. Fx will be differentiable at x equal to 0 if dash 0, that is left hand derivative at x equal to 0, or f dash 0 are finite and equal. Now, f dash 0 is equal to limit h tends to 0 if 0 plus h minus f 0 by h. Therefore, L f dash 0 is equal to limit h tends to 0 minus f h minus f0 by h. Left hand derivative. For derivative, this is as per definition. Now left handed derivative, h tends to 0 minus f0 plus h means fh here. Therefore, h is negative. For x not equal to 0, fx is defined by this. Therefore, we can write here one by h sine a square f0 as per definition 0 by h, that is equal to limit h tends to 0 minus 1 by a square sine of a square. H is very small, therefore limit a square tends to 0 sine of a square by a square. Considering a square, a new variable say k, limit k tends to 0 sine k by k, that is standard limit form, that will be equal to 1. Now for R f dash 0 also, here h tends to 0 plus. Similarly, R f dash 0 will be equal to limit h tends to 0 plus sine of a square by a square, that will be equal to 1. Therefore, L f dash 0 is equal to R f dash 0. We note both are finite and equal. Therefore, we conclude f is differentiable. From here, therefore, fx is differentiable at x equal to 0, and already we have calculated f dash 0 is equal to 1. Therefore, the first sum is solved. Now, I think you have followed, the students were following, and already I have advised that while you are following these classes, you work out the sums which we are or I am discussing here yourself and follow the steps. Now sum number 2. For that I rub this one. Given y is equal to 1 plus x square by factorial 2 plus x cube by factorial 3 plus x to the power n by factorial n. One thing I have not discussed yet, the factorial symbol. Just I discuss here. Factorial n that is equal to product of 1, 2, 3 dot 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 up to n. Also we can write in reverse order, n into n minus 1 this is the meaning. From this it is clear that factorial of negative number or fraction is not possible. Actually, in case of natural number, we take this definition also. By definition, factorial 0. The other symbol of factorial is n factorial, also written by this symbol. Now this sum dy dx is equal to ddx by applying that addition law or sum law, ddx of u plus v equal to du dx plus dv dx. I write here, skipping that step, ddx of 1 is 0, ddx of x is 1, then ddx of x square by factorial 2, that means 2x by factorial 2 means 2, then 3x square by factorial 3 is there, that is 3 into 2 into 1, then 4x cube, 4 into 3 into 2 into 1 plus this will be n x to the power n minus 1, then this is n into factorial n minus 1. Therefore, after simplification, it will be 1 plus x plus you see x square by 2 plus x cube, 4 cancel, this is factorial 3 plus n cancelled, x to the power n minus 1 by factorial n minus 1. Therefore, 1 plus x square, 2 factorial is equal to 2. Therefore, I can write this factorial 2 x cube by factorial 3 plus x to the power n minus 1 by factorial n minus 1. Here I have used one thing, you see, factorial n, that is equal to n into n minus 1 into n minus 2, 3 to 1. Now, this product is nothing but factorial n minus 1. Therefore, factorial n is equal to n into factorial n minus 1. Now, to prove this result, we have got dy dx equal to this one. Therefore, if I add this one, x to the power n by factorial n, what we get on the right side, 1 plus x square by factorial 2 plus x cube by factorial 3 plus x to the power n minus 1 by factorial n minus 1 plus x to the power n by factorial n. Now, as per this information, this is y, that is equal to y. Therefore, dy dx final step is this, plus x to the power n by factorial n is equal to y. Proved. Then sum number 3. Up to n terms in the earlier one, and here it is to infinity. That means here we have to mention. Now I take the help of this one. Number 3, it will be to infinity we can write also like this. Therefore, for this step we can write therefore dy dx is equal to this. Therefore, after simplification it will be 1 plus x square by 2 plus x cube by 3 factorial plus 2 to to infinity. Therefore, finally dy dx will be to infinity. If we don't mention this symbol to infinity, meaning is same. Therefore, dy dx, what we get? This one. First y equal to this one, we differentiate it, and after simplification we get this one, and finally this one, and this is nothing but this y. Therefore, which is equal to y dy dx equal to y. This number 3 sum is similar to number 2, therefore I have worked out like this. Now sum number 4. If x is divisible at x equal to a, as per sum if does a exists and if does a equal to limit x tends to a fx minus fa by x minus a. Already we have discussed it earlier. Now I shall use this to calculate this one. LHS is equal to limit x tends to 1 x fa minus a fx by x minus a. X tends to a, x tends to a, limit x tends to a. Now I write this expression like this: x minus a whole into fa. Actually the denominator is x minus a. Keeping that in mind, I have written this first part like this. Now a fa, that is written in excess. For balancing it will be a fa minus a fx, the whole divided by x minus a. Now I write here limit x tends to a x minus a whole into fa by x minus a plus here a is common factor f a minus fx x minus a. Now these two are cancelled since x is not equal to a. Therefore, from this I get fa. Here x is variable, x tends to a, but there is no x. That means fa is constant. Therefore, the value will be fa. Now I take minus common, minus a into limit x tends to a fx minus fa by x minus a. Therefore, this is fa minus, and already I have written f dash a equal to this one. Therefore, this is f dash a. Therefore, I can write the final step like this: limit, or write RHS. Already I started from LHS part and got the right hand side part FA minus A if dash A. Therefore, the sum is solved. Therefore, learner or students, I have finished the first part of derivative. Also, I have discussed application of derivative, and the later part, that is different rules of finding derivatives for other forms of given function, will be discussed in the part 2 or later part, as well as second order derivative or more order derivatives, also application of calculus, that is meant for class 12 syllabus.